Welcome to the Digital Union AI Foundation training. This program is designed to make you AI literate and fully prepared to meet the expectations of Article 4 of the EU Artificial Intelligence Act, empowering you with the awareness, understanding, and responsible mindset needed to lead in the age of artificial intelligence. Get ready to build the confidence and clarity to harness AI responsibly and effectively. Welcome aboard and happy learning. The program is structured into 5 key modules. Module 1, Foundation of Artificial Intelligence. Gain a solid understanding of core AI concepts, terminology, and its role within computer science and modern applications. Module 2, AI Development Lifecycle. Learn how AI solutions are conceived, built, tested, and deployed across industries, including key stages and best practices. Module 3, AI Leadership and Mindset. Cultivate strategic thinking, adaptability, and the leadership mindset required to guide AI initiatives effectively. Module 4, AI Governance. Explore frameworks for ethical, responsible, and compliant AI adoption, including risk management and accountability. Module 5, Business Case for AI and Future Trends. Discover how to identify AI opportunities, build compelling business cases, and stay ahead of emerging trends shaping the future of AI. Let's start with Module 1, Foundation of Artificial Intelligence.
The journey of artificial intelligence spans nearly 7 decades, marked by breakthroughs that have reshaped how we live, work, and interact with technology. It all began in 1955, when John McCarthy coined the term artificial intelligence, envisioning machines that could simulate human intelligence. This vision took shape in 1956 at the Dartmouth Conference, where McCarthy, Marvin Minsky, Claude Shannon, and others launched the field of AI research. Through the 1960s and 70s, AI focused on symbolic reasoning and expert systems. Programs like ELIZA and Shardloo demonstrated early natural language processing, while rule-based systems began assisting in medical diagnosis and engineering. In the 1980s, machine learning gained traction with the development of neural networks and backpropagation algorithms. AI applications expanded into finance, logistics, and robotics. The 1990s saw AI enter the mainstream. IBM's Deep Blue famously defeated chess champion Garry Kasparov in 1997, showcasing the power of brute force computation and strategic modeling. The 2000s ushered in the age of big data and statistical learning. AI began powering search engines, recommendation systems, and fraud detection. Breakthroughs in speech recognition and image classification laid the groundwork for modern AI. By the 2010s, deep learning revolutionized the field. In 2012, AlexNet's performance in the ImageNet competition proved that convolutional neural networks could outperform traditional methods. Virtual assistants like Siri and Alexa emerged, and autonomous vehicles began testing on public roads. In 2020, OpenAI released GPT-3, a massive language model capable of generating human-like text. This marked a leap in generative AI, enabling applications in writing, coding, and conversation. Then in 2022, ChatGPT 3.5 was introduced, blending GPT-3's capabilities with improved conversational fluency. It became widely adopted across industries for customer service, education, and productivity tools. By 2024, AI had become a cornerstone of digital transformation. Generative models now create text, images, code, and even video. AI governance, ethics, and regulation have become critical topics as organizations strive to balance innovation with responsibility. From symbolic logic to generative creativity, the AI journey reflects humanity's pursuit of intelligence, one that continues to evolve with each new breakthrough.
This presents a circular view of the foundational layers that make up the field of artificial intelligence. At the outermost layer, we begin with computer science, the broad discipline that provides the theoretical and practical foundation for AI. It encompasses algorithms, data structures, and computational theory, forming the bedrock of intelligent systems. Moving inward, we encounter artificial intelligence itself. AI refers to the science of creating machines that can mimic human intelligence, reasoning, learning, and making decisions autonomously. Within AI lies machine learning, a subset that enables systems to learn from data without being explicitly programmed. It focuses on developing algorithms that improve performance through experience. Diving deeper, we reach deep learning, a specialized area of machine learning that uses artificial neural networks to model complex patterns and relationships in data. It powers many of today's most advanced AI applications, from image recognition to natural language processing. Further in, we find generative AI, a transformative branch of deep learning. Generative AI models can create new content, text, images, code, and more, based on learned patterns from vast datasets. At the core of this circle is the large language model, or LLM. These are massive neural networks trained on extensive text corpora, capable of understanding and generating human-like language. LLMs like ChatGPT exemplify the cutting edge of AI's conversational and creative capabilities. Finally, we have AI agents, software entities that perceive their environment, make decisions, and act to achieve specific goals.
Artificial intelligence has come a long way, from solving narrow tasks to generating entirely new content. This slide highlights a major turning point: the rise of generative AI, which marks a fundamental shift from traditional AI approaches. Let's break it down in simple terms. Traditional AI is like a highly trained specialist. It's built to do one thing really well, like identifying tumors in medical scans or detecting fraud in bank transactions. These systems rely on structured, labeled data, meaning humans have to tag and organize the information before the AI can learn from it. They're trained with millions of parameters and typically produce one type of output, like a yes/no answer or a classification. Now enter generative AI, a game changer. Generative AI is like a creative thinker. It doesn't just analyze data, it can create. It's trained on massive amounts of raw, unlabeled data. Think of everything from medical journals and patient notes to social media posts and books. These models have hundreds of billions of parameters, making them incredibly powerful and flexible. And here's the magic. Generative AI can produce multiple types of output: text, images, code, audio, even video. It can write a poem, generate a business report, design a product, or simulate a conversation, all from a simple prompt. This shift is possible because of three key ingredients: big data. Generative AI learns from vast, diverse datasets that reflect real-world complexity. Massive computing power. Advanced processors like GPUs allow these models to train faster and smarter. Better algorithms. Deep learning techniques help the AI understand patterns and relationships in ways that mimic human thinking. So why is everyone talking about generative AI now? Because it's not just smarter, it's more versatile, more accessible, and more transformative. It's helping doctors summarize patient histories, researchers generate insights, and businesses automate creativity. It's changing how we work, learn, and innovate. In short, generative AI isn't just an upgrade, it's a revolution. It's the difference between a calculator and a storyteller, and it's only just beginning. Types of artificial intelligence: narrow AI, ANI. Also known as weak AI, it is designed to perform a single or limited task extremely well. Examples include chatbots, voice assistants like Siri or Alexa, image recognition, and self-driving vehicles. It cannot think or act beyond its programmed function. This is the AI we use in everyday life. General AI, AGI. Also called strong AI. It would have human-level intelligence capable of reasoning, learning, and adapting across multiple domains. It could perform any intellectual task a human can, such as problem-solving, creativity, and emotional understanding. Still under research and not yet achieved in reality. Super AI, ASI. A theoretical form of AI that surpasses human intelligence in every aspect: reasoning, creativity, emotion, and decision-making. It could potentially solve complex global challenges, but also poses significant ethical, safety, and control concerns. Exists only in concept and science fiction for now. In summary, driving business success. How AI enhances value and innovation. Artificial intelligence isn't just a technology, it's a business catalyst. Across industries, AI is transforming how organizations operate, compete, and grow. Let's explore 4 key ways AI drives measurable business success. 1. Efficiency improvement. AI automates repetitive, time-consuming tasks, streamlining operations and reducing human error. From processing invoices to managing logistics, automation frees up employees to focus on higher-value work. The result? Faster turnaround times, lower operational costs, and improved productivity. 2. Data-driven decision-making. AI analyzes massive volumes of data in real time, uncovering patterns humans might miss. This empowers leaders to make smarter, evidence-based decisions, not guesses. By turning raw data into actionable insights, AI helps organizations stay agile and strategic in a rapidly changing market. 3. Customer experience enhancement. AI personalizes every interaction, tailoring products, services, and support to individual preferences. Through chatbots, predictive recommendations, and sentiment analysis, businesses can anticipate customer needs and build stronger relationships. A smarter, more personalized experience leads to higher satisfaction and brand loyalty. 4. Innovation. Acceleration. AI fuels creativity and innovation at scale. It helps design new products, optimize business models, and identify untapped opportunities. By combining human ingenuity with machine intelligence, AI drives continuous innovation and long-term competitive advantage. AI isn't replacing people, it's amplifying human potential. When used strategically, it transforms challenges into opportunities, efficiency into innovation, and data into lasting business value. Driving business success. How AI enhances value and innovation. Artificial intelligence isn't just a technology, it's a catalyst for business transformation. Across industries, AI is redefining how organizations operate, compete, and grow. Let's explore 4 powerful ways AI drives measurable business success. 1. Efficiency improvement. AI automates repetitive and time-consuming tasks, streamlining operations and reducing human error. From processing invoices to managing logistics, automation frees up employees to focus on higher-value, creative work. The outcome: faster turnaround times, lower costs, and greater productivity across the organization. 2. Data-driven decision-making. AI can process massive amounts of data in real time, uncovering insights humans might overlook. This enables leaders to make smarter, evidence-based decisions, not assumptions. By turning raw data into strategic intelligence, AI helps businesses stay agile, competitive, and forward-looking. 3. Customer experience enhancement. AI personalizes every interaction, tailoring products, services, and support to individual preferences. Through chatbots, predictive analytics, and sentiment analysis, organizations can anticipate customer needs and respond proactively. A smarter, more personal experience leads to stronger loyalty and long-term brand trust. 4. Innovation acceleration. AI fuels creativity and drives innovation at scale. It helps design new products, optimize business models, and uncover untapped opportunities. By combining human imagination with machine intelligence, businesses can continuously evolve and maintain a lasting competitive edge. Artificial intelligence isn't replacing people, it's amplifying human potential. When used strategically, AI turns challenges into opportunities, efficiency into innovation, and data into enduring business value. AI's limitations, challenges, and ethical concerns. Artificial intelligence is powerful, but it's not without its limits. Let's explore the key challenges, risks, and ethical concerns shaping today's AI landscape. 1. Data dependency. AI's quality depends entirely on the data it learns from. If that data is inaccurate, incomplete, or biased, the outcomes will reflect those same flaws. In other words, bad data equals bad decisions. 2. Lack of common sense. AI doesn't truly understand meaning or context. It recognizes patterns, not purpose. That's why it struggles with nuance, emotion, or human intuition. 3. Ethical concerns. AI brings new ethical challenges. Privacy can be at risk when data is misused. And AI decisions often lack transparency, making it hard to know why a system made a particular choice. 4. High costs and complexity. Developing and maintaining AI isn't simple or cheap. It demands massive computing power, specialized talent, and continuous oversight to ensure safe, reliable performance. AI has immense potential, but realizing it responsibly means understanding its limitations and addressing them with care, transparency, and accountability.